Dear students, greetings from Dr. T. Senthilmurugan, Associate Professor and Head, Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about singly linked list. In previous video lecture, we are discussed about what is linked list, how the memory will be allocated, how the memory will be deallocated, and what is the advantages of linked list and disadvantages of linked list. Comparison between array and linked list. These are the topics we are discussed in the previous lecture. In type of linked list, the singly linked list, doubly linked list, and circular linked list are there. So out of these three, in this video lecture, we are going to discuss about singly linked list. So this is classroom discussion topic 24. This topic will be discussed in week 8 and lecture 3, singly linked list. So before going to discuss about the concept of singly linked list, we must know this outcome of this lecture. After completion of this lecture, students will be able to develop a C program to create a node in singly linked list and perform traverse, search, insert and delete operations on linked list. So what is singly linked list? The linked list can be defined as collection of objects called nodes that are randomly stored in the memory. So these basic things we are discussed in the previous video lecture. We already know it's linked list means a collection of nodes. Each node have the two portions. So in this portion, first portion is data portion, second portion is link portion, that is pointer portion. This pointer have address of next node. Okay. So this entire things we consider as the node portion. Okay. So here we have the head pointer. This pointer is pointing to the first node of the linked list. In this linked list, this is the first node. So this address will be stored in the head node that is pointing to the first location. After visiting this node, it will goes to next node. This address of second node will be stored here. This link will be established to connect the next node. So this node have address of this node. So when the node have null pointer, that will be considered as the last node of the linked list. Okay. So uses of linked list, where we are using the linked list, how it is useful. Okay. So the list is not required to be continuously present in the memory. So in case we don't have continuous memory, so the memory, if you want to add more number of data or records, if we don't have continuous memories in the memory, main memory, so in this time, we used the linked list wherever the memory is free. It is not continuous. Wherever the memory is free, it will be used as a list. This list have the link with the next free space or where the next data is stored like that. It is making the list. Okay. So this is achieves the optimized utilization of the space. So if there is no continuous memory available, this linked list will utilize those wherever the free spaces is there in the memory. It will be utilized by the linked list. The list size is limited to the memory size. Okay, so why we are saying that how the memory is available up to the memory size we can extend the list. Once the memory is over, we are not able to extend it. So list size is limited to up to memory size. So it does not need to be declared in advance. So normally in array we have to declare in advance itself. Example, how many records? If in this int type of that the student roll number we want to give, that roll number if we are represent that, if 65 student means we must be declared what is the maximum size of that. This is static array. So here in advance itself, like before compiling itself, we define that what is the size of the memory required for that. So here in linked list it is not required. At the time of execution we can allocate the memory as well as deallocate the memory. That is the advantage of linked list. Empty node cannot be present in the linked list. So if you are creating the node, there is no data. This is empty node. Okay, so this is called as empty node. If there is no data, there is no pointer, means this will not be considered as the node of the linked list. We can store the values of primitive types or objects in the singly linked list. So primitive type means already we know integer, float, double, those data. Those type of data we can store in the linked list. Why use linked list over array? So already we said, okay, array is continuous memory allocation. Okay. So in array, we have to allocate the memory continuously. Because if there is no continuous memory allocation, we are unable to allocate. So, but in linked list, we can use this space wherever it is available. So we can use the free pool concept and garbage collection concept for allocate the memories. It will be utilize the memory properly. And array have several advantages. Even we can access randomly. Array we can access random position. If in case I want to add data in this current position, means I will shift the data to one more position. So then this will be shifted. I can insert here. Okay. So this is possible in linked list also, but we cannot access this randomly. Wherever we want to access, it is not possible. So in linked list, we can access start from the head pointer. Then it will access through sequential only, sequential access. So that is the drawback of linked list, but it is advantage. Even we have more advantage in the array, but we will refer to the linked list compared with that memory space occupation. Okay. So both it is have advantage and disadvantage. We can decide which is suitable for our requirements. Okay. So the array have what are the limitations? Size of the array we must be know. Okay, so we are unable to allocate at the time of execution. I'm not saying about dynamic array. I'm saying about the static array. So increasing the size of the array is time-taking process. Okay, so if in case you want to increase means again you have to change all the declarations and allocations. It is almost impossible because it is continuous memory allocation, no? So if we already declared like this, so in case I want to extend means this remaining continuous space will be available or not, we don't know. Okay. So if memory already occupied with these spaces, continuous basis, so you are allocated 65 already. 65 memory is continuously allocated. Suddenly you want to add some 5 more members means this continuous memory will be allocated here or not, we don't know. Okay, that is the impossible things. Even that the runtime, we are not able to change these things. Okay. So increasing any element in the array needs to shifting all the cell predecessors. Okay, so we know that if you want to insert here means this element, all the elements of the remaining this will be shifted to next cell. Okay, so even if you are deleting also, one cell will be forward to up to last cell. So this is time taking process. So this will not be happen in the linked list. Linked list is the data structure which can overcome all the limitations of the array. Okay. So now what is the useful? Memory will be dynamically allocated in linked list. Okay. That means at the time of execution, we can allocate the memory. And non-contiguous memory allocations. Again, no need to continuous memory. And sizing is no longer a problem. So till memory is available, there is no problem. So list grows as per program's demand and limited to available memory space. At the time of execution, how many memory we want to, we can allocate. But only limitation is the memory should be available. If it is not there, then we are unable to do that. Okay. So now we will go with the singly linked list. What is singly linked list? Whatever we are discussed as of now, that is considered as a singly linked list. Singly linked list means it's only single link and single direction will be there. Okay. So link between that another node is only single. So what is the advantage of this means? We can sequentially access from the head pointer, then forward direction we can use easily. Okay, there is no reverse direction. Reverse direction you are unable to move. So there is a sequential access, we can move forward only. We are unable to reverse it. Okay. So we know that each node containing the data part and link part. Data part is actual value will be stored there, and second link part is the address stored for the next immediate successor node. So we can say this is one-way chain or singly linked list. It can be traversed only in the one direction. I already said single direction or forward direction. There is no reverse direction. Each node contains only next pointer. So the next pointer is pointing to forward direction, not in the reverse direction. For example, where the marks obtained by the student is 3 subjects are stored in the linked list as shown in the figure. So it will show that each student, whatever mark he got, first mark, second mark, third mark, like that, it will be there. We are unable to access from reverse direction. So last node will be represented using the null pointer. We know that. So null pointer in structure we are representing using EX symbol or cross symbol. So we can add any number of elements as we required. So this is the time complexity when we are considered that the average time. That average means the theta of n access for search element theta of n, for insertion theta of n, deletion theta of n. But worst case order of n. Okay, so because in case if you want to insert the node in the last means it will take all the nodes it will visit, then finally it will add. If search element, the element is available in the last position, then that is worst case. Okay, so here insertion also, the first position if you are inserting, that is order of n. Okay, in the worst case means how it may be deleted in between the node. So what is the time? The particular node we are deleting, no, so it will take only order of 1. So deletion also order of 1. But here space complexity means how much time it will take. If you want to add new thing means we can, how many nodes are there, that much node we have to assign. There is no free space in between. If 5 nodes are there means 5 node it will occupy the memory. Okay, how many nodes are there? All the nodes will be occupied the memory. There is no free space in between. So already we have discussed about how to create the node using this 5 lines of code. We are creating the node. So this node we are saying that this is the node. This node have two portions. First portion is the data. Already I told data portion. Second portion is the pointer. So this pointer is pointing to next node. That is storing the address of the next node. So here we are creating two pointer. One pointer is head pointer is pointing to the first node. Second is pointer. This is pointer getting the node address. Okay, after creating the node, it will return the pointer value. So this pointer value, how after allocating the memory, it will be returned by the operating system. So how to insert? So we have 3 combinations of insertion. I already said. Okay, so the node will be how like this. If in case 5 nodes are there, and the start pointer is pointing to the first location. Each node have 2 portions. Then the last node have another portion. Then here like this, if the last node have the null pointer. So in case we can insert here at the beginning, okay, at the beginning, at the beginning, at the end, here also we can add at uh, at the end position. So in case after the node, okay, wherever in between any nodes, so in between or randomly, okay. So these 3 category we will check it, we will discuss now. So we have 3 options to insert the node at the beginning or at the end or in between some nodes or after the node we can have. So insert at the beginning, what we have to do? Okay. So you just think about it. First, the node is there, the list is there or not, we have to check because start pointer is have any values. If you have values means the node is there in the list. Otherwise, we have to create the new node. So first, what we have to check here is pointer. So already we discussed. We are creating this pointer. One data item we are created for give the data value. After that, the memory allocation will be there for the node. So that will be written the pointer value. That pointer value equal to null means there is no memory. Okay, memory is full. So we can print overflow or memory is not available. So otherwise it will return some values, no. So that means the memory will be allocated. So memory will be allocated. Node is created in this situation. Okay. So here what happened? So after that we will get one item value, that what value we are stored in the node. So simply we can say that pointer tends to data. So this portion is considered as pointer tends to data. Okay. So this portion is considered as pointer tends to next, because we are created next pointer. Okay. So pointer tends to data is item, whatever value we are getting that will be stored. For example, you will give the value is 5 means 5 will be stored here. Okay. So after that pointer next second portion. So what you have to assign? Head portion. So it is the first node you consider. Okay. So what happened? Head node will be assigned. What is the head value initially? So whatever value is stored for this. Okay. The what we are doing that initially head equal to, the head value will be assigned to this next. So what is the head value? Pointer value. This pointer whatever it is there, then this value will be stored in next head pointer. Okay, the node is created. This is the node. So now this pointer is there. No, this is a common pointer. After creating this node, this address is pointer. Okay, so this location, this pointer tends to data this portion. Pointer tends to next this portion. This pointer will be written to there. So this address is stored to head. Okay. So head will be assigned to this value. So what is the meaning? The now head is pointing to this node. Okay. This is node inserted. At the beginning, when we are insert at the first location. So that is the case we have to check. In case last location what will be happen? So we have to check initially again the node is there or not. If we have to create one node. First, we have to create the node. Okay. So what we will do, same like that. PTR. We have to allocate the memory location. So in this, it will be created the memory, and it will assign the address is PTR. First portion is data. Second portion is next pointer. So if we are not getting pointer equal to null means memory is not available. Memory is not allocated. This node is not created. If not, else means memory is allocated, some value is there. Means, so under the value where we have to insert, what value we have to insert. So that value we are taken as the item value. Pointer tends to data. This is the first location. Pointer tends to data means this portion, first portion. So this portion, whatever value we are given, that we are assigning it. Okay. So this is assignment operator. Assigning the value to there. Next we have to check head equal to null or not. Head equal to null means what is the meaning? So there is no empty list. Okay. So in the empty list we are creating last only one node. In that time, what we have to do? Pointer next equal to null. That means this portion we are making as nil because there is no node previously. Only one node you are created, first node. So you can give pointer tends to next equal to null. Okay. So this portion null you are make it. Whatever data you are given, if example you are given 6 means 6 will be stored here. So this node is created. After that head equal to pointer. So pointer value assigned to head equal to pointer. So now you are assigned these values. Okay, node is inserted. So what is the meaning of that? Last insert also it will check memory will be created. After if it is memory is not there, we can print memory not available. Otherwise, we can return the pointer value. If only one node is there, then this is the procedure. In case already some nodes are there, what is the procedure? So here you can see that. Okay. So what you can see at the last node we are inserting the element. So we don't know what is the head node it is finding. So because it is sequential access, we can move up to last node. So example, this is the head node. head will pointing to the first node. So here the next node is there. Here then next node is there. So this is the last node. So I want to insert here. So I will create one node. This node I want to insert here. So what I have to do? First I will come here. So my pointer will comes to up to null pointer. Okay. So for that initially we are storing the temp pointer equal to head. Okay. So initial pointer will move. So head pointer if move means again it will be confusion. So we can create one temporary pointer. The temporary pointer we are assigning the head. So now temp also pointing to the first location. Whatever it is pointing head, that will be pointing. So what we are doing, this loop statement, temp not equal, temp tends to next not equal to null. Temp tends to next means it will pointing to this location. This location not equal to null means you will go temp equal to temp tends to next. Again, this value will goes to next positions. Okay, so it will go up to null pointer. When it is meeting here, this loop will be over. Okay, so now temp pointer is pointing to this location. Okay, so what we have to do? This temp next equal to PTR. So the PTR is the new created memory. No, so temp next equal to PTR we can assign. So because previously it is null, so now we are assigning PTR value. So this PTR next equal to null. So this node we are making null. So this is insert at the end position. Again random position. So random position also we can move to up to that node. Okay. So first initially we are creating, we will get that location and item values. Two pointers we are creating. One pointer is for allocating the new node. Another pointer is temporary pointer. So the new pointer is used for allocate the memory. This line will create the memory locations with two portion. This is data portion. This is the next portion. So it will check PTR equal to null. If null means there is no memory, it is not created. Okay. So this statement is common to all three cases. Here, enter the element value. We will get one value. That value we will store it here. Okay. So whatever value, if example you will give 8 means 8 will be stored here because this is the PTR node. This node is created. PTR tends to item data. That is item value. It is assigning. You are assigned that. So next, what happened? So location, which location you want to assign. So the first node have 0th location, head node. Then remainings are first location or second location. Like that, it will go third location. Then last node, maybe the fourth locations. Okay. So if you want to insert my node in that third position, okay, third location means what I have to do? I value up to 3. So 0 to 3 it will move. So here we'll start from 0. No, that's why we are starting. Where we have to move? Initially head pointer is pointing. Here assign the head value to temporary pointer. Temporary pointer will move up to position. Okay, up to location it will move. If in case it is null pointer, given location is 4. In case if you are given location is 4 means there is a null pointer is there, no? So you don't insert, you are unable to insert because by inserting last node we are written separate function. Okay. So this is not category for that. Here only if in between middle only we are inserting it. Before 4 or after first node we can insert it. So that's why we are checking this condition. Temp equal to null means it is the last node. This is not satisfy this condition because we are explaining about random insert. So it is not there means in case the values are here 3, it is not null pointer. So this pointer value we don't know. Clear. So in this location what we will do? So PTR next equal to temp value, temp next. Okay, what is the PTR? So this is the PTR. We are creating this node, new node. What we have to do? This PTR next means this portion. Okay, this portion. Now temp is pointing to here. Temp is pointing to this node. So temp next, whatever address is there, that we are assigning to this location. So what is the meaning? After assigning, this make link here. This link will be cancelled. Okay, this is the first statement. These statements are changing the pointer. Temp next equal to PTR. So what is this? Again, so this portion we have to assign this address value. So this address value we are assigning to here, So what happen after assigning? This link will be created to this node. Okay, this is this statement. This statement is used to creating link between this node. So finally, node is inserted because this address will be changed here. Then this address will be stored in previous node. Okay. Insert operation over. Delete operation also same at the beginning. So at the beginning, at the end, and after specified the node. So how we can do that? The beginning means what we will do simply we have to check head is null. Null means list is empty. We are unable to delete the node. Otherwise, we have to change ptr equal to head because what we have to do here ptr only one pointer we are taken. That pointer is pointing to the node. Head pointer we are assigning. Okay. Head is pointing to pointer next. Okay. So what happened? This is the node. So it maybe we will take this is the ptr. So this is the values are ptr next. So here what it will be there? ptr tends to next. This value is there. Okay. So this is binding to this node. So it may be ptr plus 1 you consider. Okay. This is ptr. This is ptr plus 1. What we will do? Head node is binding of this node. So what we will do? Whatever node is there, whatever address is there, I am assigning to here. So if I am assigning means what happen? Directly the link will be goes to here. So this node will be removed from the list. That is we are using free of PTR. Got it? Okay. So next last delete. So if you load in the last node, okay. So the list is there. So we have to traversal. This is last node means that we have to come with this pointer to up to null pointer. So once it is comes, what happen? We are unable to go to reverse direction. So for that reason, we will use two pointer. Okay. So what is that pointer? How it is working? For example, this is the list will be there. You just consider in list 3 nodes are there. So here null pointer is there. Here head pointer is pointing to first location. You consider like that. Okay. So each node have the list like that link is there. So what I will do now? First I will check list is empty or not. Head is not equal to null means some nodes are there. Then what we have to check? Head tends to next equal to null. So that means this portion is not null. It is not only one node. Means we will delete the last node. If it is not null means what we have to do? Head equal to null. Okay. So in case it is null means we are deleting only one node. So then simply we can assign this equal to null. So that means first node it will be removed. It is not null. If it is equal to null means only simply you are changing head pointer equal to null, free the head. So first node, only one node is there in the list. Okay. So how it is there? You just think head is there, only one node in the list. This is null pointer. So in this situation, we are written this code. Okay. What is this head pointer? So already head pointer of next equal to this is head pointing here. So head data is there, head next is there. Head next equal to null means what happened? So this pointer will be removed from the list. Only one node is there, one node we are deleted. So it is not one node, there is no memory means many thing is there. Now we have to do. We are assigning head pointer for initially to PTR. PTR next equal to not equal to null. PTR next means if in case you are taking this PTR1 pointer, this pointer pointing to here. The PTR next means this node, first node. This node is not null. Okay, then what we have to do? If not null means it will goes to last node. So PTR will move to next node. And what we are doing that PTR equal to PTR1. Okay, PTR value will be assigned to PTR1. PTR equal to PTR next. So what is the meaning of that? We are creating two pointer. Please carefully listen. PTR1 and PTR, both the pointers are pointing initially here only. If it is not null, what we have to do? This PTR value is there, no? This address will be assigned to PTR1. The PTR next will be goes to next address. So now PTR1 is pointing to this node. PTR is pointing to this node. Okay. So now this loop will be extend up to null character. So when it is null, pointer is coming to here, pointer next. So now PTR1 is pointing to this node. Here PTR is moved. So now PTR is reached to null pointer. PTR next equal to null pointer. So what we have to do? PTR1 is finding here, PTR is finding here. So now we are moving up to here. So what is the meaning of that? So PTR pointer is PTR1 is pointing to previous node of last node. PTR is pointing to last node. Okay, this situation we came. This is the last node. So now we want to remove this. What we have to do? PTR1 here. PTR1 next equal to null. So PTR1 next means this portion is null. So then free PTR. This PTR is there, no, free. So this memory will be removed. Okay. So got it? So now this is the last node. So for that reason we are created two pointers. In case random delete, for the random delete also we have to follow the same, but we will get the location up to location. Previously up to null pointer we are moved, then we are removed. Here up to location we have to move. Initially pointer is head, we have to move that pointer and pointer 1. So pointer 1 is pointing to the current location, PTR is pointing to the next node. Okay. So PTR is equal to null means you can't delete, because we have separate procedure for delete the last node. But if it is the not last node means this pointer will move up to last node. Okay, so up to location. So up to location, whatever location you are given, fourth location or fifth location, up to that location it will be moved. Which will be moved? So up to location, once it's reached the location, pointer is pointing to the pointer next. Okay, so here these nodes are there, 3 nodes. Here it is pointing. I want to delete this second location. Okay, so head is the first location, 0th location. This is first location, this second location, this is the third location. I want to delete the second location, which here I am creating two pointer initially, PTR, PTR1. So first initially it is pointing, PTR value is head pointer. Okay, PTR1 is head pointer, PTR is head of next pointer, will be pointing to this location. So now it is moving to here. We'll check. PTR is pointing to here. PTR1 is pointing to here. Okay. So this node it is pointing, this node it is pointing. After reaching this, it is not null. So what we will do? PTR1 next equal to PTR next. Okay. So whatever value it is there, that will be assigned to here, because this is a PTR next, this is a PTR1 next. So PTR next address will be assigned to PTR next. So if automatically what happen? The link will be followed to here. Okay. Previously this address will be there, 2 will be there. So now it will be 3. Okay. So example, it will change that value. Initially this address will pointing to this node. Initially this node will be deleted. Okay. So this is the delete operation. Display operation means all the nodes. If there is no empty list means we can check each node. So it will PTR pointer is not null means up to the last node we can move. Okay, we can print all the values which is now PTR data. For all the nodes we will print up to null pointer. Search pointer we will take the key value. That value is there or not we have to check. So whatever value is there we will take it here, and we will move the pointer up to null pointer. We will check pointer tends to data equal to item or not. We will move one by one. If the data is found means simply it will print that which location, what is the value it is printed. Then flag value will be 0. Otherwise flag is 1. So we have to move I plus plus up to this pointer is moving to null pointer. So after reaching null, the flag is 1 means there is no data item found in that list. Okay, so now we are in the last location. So delete operation, search operation, find operation, all the operation we completed. So now you see you have to answer for this question. Whatever answer we will do. If in case we want to delete the last element, what we will write it. Okay. What we have to null, first we have to check. Head not equal to null. So list is empty. Otherwise, what we will check here? If what condition we have to check? 1, 2, 3. I will give 10 seconds time. You just write the answer for this. Okay. What condition I will write here? So what is the last node means first we are checking. So head is null or not. If empty list means Next, only one node is there. This condition you will consider. Only one node in the list. So what is the condition we have to check? What we will write? Here what we will write? Okay, our time over. We'll discuss now. This is head tends to next because first node. Okay, head is pointing to the first node. So that next node is equal to null means we will change it. Head equal to null. Only one node we are removing. Here PTR equal to head we are checking. So now PTR next not equal to null. Up to that point we have to check. Okay. So here also PTR equal to PTR tends to next. So because we have to move to the next location up to null location. Okay. So these are the conditions we have tried. So for this is the answer. I hope you understood how to perform the single linked list operation. We have discussed about the introduction of single linked list and operations of single linked list and program for all the operations we discussed. So now you are able to write the program for that. Write a C program to create 5 nodes in the linked list and insert and delete 3 nodes in friend, middle and last respectively. Also display after each operation. You have to show all 3 operations in the program. So now we are revisited the lecture outcome. Having completed the discussion on single linked list operations, students should be able to develop a C program to create a nodes in the single linked list and perform traverse, insert and delete operations. So I hope you are enjoyed this video. Thank you very much for listening with patience. If you have doubt, you can read the chapter 6.2 in Srimata Raja textbook. Even further doubt, we will discuss in the classroom discussion. Thank you all once again.